Did you want to do in the homework? 21. 6. 9. 4. You need 3 also? Okay. Here we go. Number 3. Yeah, these are hard. That's why we do 3 to 6 a day. Some of them were easy for you? Oh, that's good. You do? I like them too. I usually, word problems have never been my favorite either, but okay. Number 3, maximizing perimeter. It says, what is the smallest perimeter possible for a rectangle whose area is 16 square inches and what are its dimensions? All right, so I set up a rectangle. Okay, and these are going to be squares, but we can't set up a square. It's a rectangle. And it says the smallest perimeter for a rectangle whose area is 16. So x times y is 16, and I need to minimize the perimeter. And the perimeter is 2x plus 2y. So I need to take the derivative of perimeter, but right now it is in 2 variables. I'll get it into 1 variable by solving for y in the area equation. So y is equal to 16 divided by x. So I'm going to take that and plug it in. Perimeter is 2x plus 2 times 16 over x. So we get p equals 2x plus 32, x to the negative 1. All right, take the derivative, because whenever you're trying to find max or min, you want to take the derivative and set it equal to 0. So derivative of 2x is 2. Derivative of this is negative 32x to the negative 2. And then set that equal to 0 and solve. 2 minus 32 over x squared equals 0. I would add 32 over x squared to the other side. Cross multiply to get 2x squared equals 32. Divide by 2, you get 16. Take the square root. You don't need the plus and minus square root. You just need the square root, and you get 4. All right, plug it back into your original where you have y equals 16 divided by x. So y would also equal 4. So the perimeter would be 16. Do they ask for the perimeter also? Yep. What is the smallest perimeter? So these are both in inches. Don't forget units. I tell my son that if the problem has words in it, your answer has words in it. Right? 16 square inches.
How do you know if you're trying to find the smallest?
Good question. For this one, if you were to take the second derivative, which I don't make you do, this is always concave up. That means it's going to have a minimum. So they ask you to find the minimum. I will never ask you to find the maximum when it's a concave up problem.
So if they're saying how to find the largest area, it's the exact same process.
It is, but it'll be upside down. It'll be a maximum.
Okay, we don't
yeah.
have to think about that.
You don't. I never mess you up. In an AP Calc, I think they make you actually take the second derivative and find out that it's concave up or down.
Confused me when number 3 was asking for the smallest and number 4 was
Right,
asking
for the largest, yeah. They'll ask you for the largest area, but then they'll ask you for the smallest perimeter. So if you're making a pen for your animals, wouldn't you want the largest area possible? Yes. But if you're using material to go around the outside of it, don't you want the smallest amount of material to use? So they're 2 separate problems. It's weird. It's like you want the maximum area, but the smallest perimeter. All right. What was the next one you wanted? That was 3. 4? You guys wanted 4? Okay. Number 4 says, show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. Now, when you're telling me to show you that it's a square, you can't just assume it's a square. It's a rectangle, okay? We're going to show you that it actually is a square. So this one right here, 8-meter perimeter. So 2x plus 2y is equal to 8. And we want to get what? The largest area. The area is xy. Okay, so we have 2 equations. We're going to solve for y in one of them. So let's go ahead and solve for y here. We're going to subtract 2x to the other side. 8 minus 2x. Divide everybody by 2. Y equals 4 minus 2x. Take that. Oh, whoops. Y equals 4 minus x. Thank you. All right, so we get area equals x times 4 minus x. I would probably, instead of doing product rule, I'd probably distribute. So you get 4x minus x squared. Take the derivative. You get 4 minus 2x. Set it equal to 0. X equals 2. When you go back up to where y is 4 minus x. Y is also 2. And so I just showed that it is a square. It's a 2 by 2. Pretty good, huh? That was a fun one. All right. You didn't want 6, or did you?
Yes.
Yes, 6. Okay. Number 6. Here it says that we have a parabola, right? Let me see. Yes, a parabola. Y equals 12 minus x squared. And we're trying to find the largest rectangle, the largest area. What are its dimensions? And it's inscribed in it. So here's our parabola. This right here is 12. And then we have this rectangle in here that's going to have the largest area possible. Okay? So we label this x right here from here to here, which means that this is the point x. And if you plug x to find out what y is, it's 12 minus x squared. So that means that the base is 2x, and the height is y to here, the y value of that, which is 12 minus x squared. Okay? And so the area of this thing would be 2x times 12 minus x squared. So let's distribute the 2x, so I don't have to use product rule. So I get 24x minus 2x cubed. Take the derivative to get 24 minus 6x squared. Ooh, that's going to be nice. Set that equal to 0 and solve. So we'll add the 6x squared. Ooh, that scared me. Divide by 6, x squared is 4, which makes x plus or minus 2. And of course, we're going to choose positive 2. All right, that's not the answer, though. Then you have to go back and say, okay, what are they asking for? What is the largest area, and what are the dimensions? So let's find the dimensions. It says the base is 2 times x, so the base is 4. And then the height is 12 minus 4, so it's a 4 by 8. It's a 4 by 8, which has an area of 32. Nice. Who got that one? Yes. Are you super proud of yourselves?
Yeah.
You see what you did?
I just didn't multiply it. I just had x is 2.
So you just didn't finish the problem.
Like
You got all the hard part right.
Yeah, I got like y is 8 and
Oh, okay.
because I plugged it back in. But
Oh, right. You plugged it in, but you didn't plug it in for the base. Good. Okay, and then did you need number 9?
yes,
Yes, number 9.
I had 21.
Oh, we're just going to do them all. Okay. Number 9.
Don't need it.
The best fencing plan. A rectangular plot of farmland will be bounded on one side by a river. Okay. And on the other 3 sides by a single strand of electrical fence. Let's zap those animals. Zap. Terrible. You have 800 meters of wire at your disposal. What is the largest area you can enclose, and what are its dimensions? Okay, so this is x and this is y. We're trying to find the largest area possible. See, they did this river thing so that the perimeter isn't always just 2x plus 2y. In this case, it depends where you put x and y. So mine is going to be the perimeters 2x and 1y. Yours could have been 2 y's and 1x.
I did too.
Yeah, it doesn't matter.
Okay, I think it's good.
Really? Are you sure?
That was the only like that was kind of like the only thing I was confused like.
Oh.
Lay it out.
Yeah, it doesn't matter. It doesn't matter which one's which. So it's a 200 by 400 or it's a 400 by 200. Do you need me to keep going? Anybody?
I just did the math wrong.
Oh, let's do it then. What did I say? Oh, the perimeter is 800. So let's change that P to an 800. So I would solve for y. Y equals 800 minus 2x. Take that and plug it in for y. So the area equals x times 800 minus 2x. Distribute the x. So it's 800x minus 2x squared. Take the derivative. 800 minus 4x. Set that equal to 0 and solve. So 800 equals 4x. X is 200 meters. So this side is 200 meters, which means that the other side would be 800 minus 2 times 200. So 400 meters for the other side. And then you find the area by multiplying those together. Ends up being 80,000 square meters. 80,000 square meters. Okay? All right, and then the last one, number 21. It says here that y is equal to 4 cosine, where is it? 4 cosine of 0.5x. And we have to, from negative pi to pi, okay? And we have to get the dimensions of the largest area rectangle inscribed in that area right there. Did anyone get this one?
No.
No? Yeah? Good. It's a hard one. All right. I would graph that on my calculator if I needed to. Personally, I don't need to, but what stuck up. I know, right? I'm so mathematically cool. Does that make me bad? Okay. All right, so here it is, and this is negative pi to pi.
That just looks like a cosine wave.
Yes, it is, but the period has changed because of that 0.5. So the period's really 2 pi over 1/2. The period's 4 pi. So cosine usually goes through pi over 2. It's being spread out to pi instead because the period's now 4 pi. But you haven't done that in so long, huh? And so it looks a lot like the parabola problem that you did. Not so much like the sine one that we did yesterday. So this, you always call from the origin to the edge of the square rectangle, you call that x. So that's x. So then the base would be 2x again.
Wait, I thought you said that.
Mm-hmm.
Oh, wait, never mind.
From the origin
Parabola.
to the side, yeah. And then the height here would be whatever the y value is. Well, guess what the y value is? It's that. So the height would then be 4 cosine of 0.5x. And so then the area of the entire thing is going to be the base, which is 2x, times the height, which is 4 cosine of 0.5x. Now, I wouldn't make you take the derivative of that. You could simplify this a little bit to be 8x cosine of 0.5x if you wanted to. But I wouldn't make you take the derivative of that either. You can graph that on your calculator and then find its maximum x value, or the maximum that the x value occurs at, okay? So you go to your calculator. King suck. Nice. Thank you, Wyatt. That was great. What a jerk. Can you see that? Yeah. Okay. Anyways, y equals 8x times the cosine of 0.5x. And I would probably make sure that I'm in radian mode. And I would just hit zoom trig. All right. You want to change the window a little bit? I don't know how high it goes up. There we go. Overkill. Okay, so now I have to find the x value where that maximum occurs. This is not the derivative. This is the function. I'm trying to find the maximum of the function. That's where the derivative equals 0. Because we're trying to find the maximum area. So we want to find the maximum x value. So calculate the maximum, number 4. Enter. Enter, enter. X turns out to be 1.72. All right, so x equals 1.72. And then what you're going to do is then you're going to go back. After you get that, the rest of it, you know, it's pretty basic. So then the base would be 1.72 times 2, which is 3.44. And then the height is 4 times the cosine of 0.5 times 1.72, and that ends up being 2.61 when you plug that in. And then to find the area, you just multiply those two together to get 8.98. So yeah, that's tough. The height is right here in red. So you just plug in. You'll go 4 cosine of 0.5
Have that so fast?
times 1.72.
How'd you have that so fast? Oh. Okay.
The first year I taught these,